fly. You're going to see this. You're going to see we're going to have a lab. You're going to have worksheet questions where we talk about pop flies. And what I want you to understand, for one, is that if you have nothing but time, you can figure out a whole lot about what happens when you throw a ball up in the air. So if I only have a stopwatch and I throw a ball straight up into the air, just with a stopwatch alone, I'll be able to figure out exactly how fast I threw the ball, the velocity I can throw it with, as well as the exact height it reached. Okay, and that's only with using a stopwatch. The reason being is that we know so much more. Since we know enough about gravity and we know what happens when a ball goes through the air, we know a lot more than you think. Okay? So, starting out, first I say that I throw, this is obviously not drawn to scale. Okay? I throw it at 49 meters per second. 1 second compared to that, that won't be the same thing. But just a general idea. Okay. First off, if I want to know what the velocity is after 1 second, what is the actual acceleration of gravity? 9.8. 9.8. And in this case, if I said the velocity here is positive, if I say it's going up at 9.8, I'm sorry, going up at 49, anything going down has to be negative. Okay? This is where direction's important. You can, as long as you're consistent, you won't get yourself into trouble. But if I say going up is 49, I know that gravity always pulls down. Always, always, always it pulls down. Okay, so I know that the acceleration here is negative 9.8, and it will never change throughout this picture. Alright? So, the acceleration at every point here is going to always be negative 9.8. So I can write, alright, after 1 second, my acceleration is negative 9.8, because it always will be. Gravity doesn't change. Gravity doesn't stop pulling just because something's in the air. Now, if I want to figure out velocity, all I have to do is use my first equation, my V final. V final is equal to V initial plus AT. Alright? My initial velocity here will be always 49. No matter where on the picture we're talking about, I said that my initial velocity is 49. So I have 49 plus A, which is negative 9.8, times my time, which is 1. What do we get that velocity to be? 39.2. Okay. So, you'll have a question. You're going to have a picture. I guarantee you're going to have this picture on your test. Test, maybe midterm. I guarantee it. Okay? And you need to figure out at every point what the velocity is. But as long as you know the time, you can figure out the velocity. Just use the VF. Alright? It's always going to be negative 9.8. That's the acceleration. Now, the peak is very, very important and very special. No matter what, wherever you are at, and like I said, this is not drawn to scale. But the peak, at the peak, alright? This ball goes straight up, straight down, right? At the peak, what do you think the velocity will be? Zero. The velocity will always be, no matter who's throwing the ball, no matter what's happening, if something goes straight up and straight down, at the very peak, the velocity will be 0. It's only for a split second, okay? A tiny, tiny piece of time. But for a split second, the velocity of the peak will always be 0. If you think about it this way, the ball goes up, it comes back down. Wherever it's at the peak, just before it hits the peak, it's going up. So it has a positive velocity. After the peak, it's going down. It should have a negative velocity. So to go through from a positive to negative, you do have to find a 0 point. It has to be 0. That'll always be at the peak. Okay? So right away, anytime you see a picture like this and you see a peak, you know that the velocity here is 0. I'll ask that question on a quiz, and hopefully I think everyone will get that question right. Here's a question I'm going to ask on a quiz that unfortunately some people are going to get wrong. Even though I'm telling you right now it's going to be on the quiz and people are going to get it wrong. The acceleration never stops. Gravity doesn't turn off just because a ball is at the peak somewhere, right? So what is the acceleration always going to be? Negative 9.8. Gravity doesn't turn off just because a ball is at the peak. Okay? I'm going to have a question where I say, what is the acceleration up here? And because people think that the velocity is zero, or people see that velocity is zero, for some reason they're going to think that they have to have acceleration zero. It's only zero. Velocity is only zero for a split second. Okay? A little bit before it was going up, a little bit after it's going down. Gravity doesn't turn off. So gravity will always have to be negative 9.8. Alright, this is what I want you to do. I'm going to give you a minute to do this. Since we know that the velocity here, we'll say that's v final right now, just for this question. Alright? My initial velocity is going to be 49 always. We have acceleration, negative 9.8. I want you to solve for t and figure out, given the velocity of 49 meters per second, how long is it going to take for the ball to reach the peak? We'll pause there for station identification and let you work. Recording? Here we go! What do we get the time to be? 5 seconds. So, if you used your first equation, VF equals VI plus AT, solving for t, you have VF minus VI divided by A equals a time, 0 minus 49 divided by negative 9.8. The negatives cancel out, and we get 5. 5 seconds. So it took 5 seconds to go up to the peak. Now, here's the next thing I want you to understand. Anytime a ball goes up and comes back down, it will always be symmetrical. Okay? So if it goes up and comes back down, if it takes 5 seconds to go up, it's going to take 5 seconds to go back down. The total trip will always be twice whatever it took to go up. Or vice versa. You're going to have a lab where you throw a ball straight up in the air, and you time how long it takes to go up and come back down. The time it takes to go up and come back down, you can split in half, and that will tell you how long it takes to reach the peak. That's useful for figuring out the velocity you threw the ball up with. Okay, so for these trips, and actually I think I do that on the next slide, so I won't jump too far ahead. But we'll be able to figure out right away, if it took 5 seconds to go up, that means it's going to take 10 seconds to go up and come back down. Make sense? Okay. Now, here's the next thing I want you to see. B and D, I'm going to say, are the same height. Alright? If B and D are the same height, you can automatically say what the velocity is going to be here. It's going to be whatever the velocity is here, but negative. Okay? So anytime something goes up and comes back down, let's say I throw this ball up at 50 meters per second. When it comes back down into my hand, it will be negative 50 meters per second.
Does that mean
always, always, always.
Does that mean you switch acceleration to?
No, and thank you for asking. Just because something is falling down, the velocity now is negative, but the acceleration is not negative. Okay, and students often get confused, and all of a sudden when things are going down, they decide to change it from a negative 9.8 to a positive. Gravity's still pointing down, right? And the negative sign just means direction. So gravity's still pulling down. We're still saying down is negative. Don't make that 9.8 positive all of a sudden. Okay?
So
Just say again.
gravity's always negative 9.8?
Gravity's always negative 9.8. Okay? Now, I'll tell you this. There's times where we get lazy. If I have a problem where I drop a ball, okay, and I do that, I might just say, alright, because if I drop a ball, I need to say, if I say acceleration is negative 9.8, that means velocity is negative, my distance has to be negative, everything's going to be negative. Okay? I need to be consistent. There's times where we'll just get lazy and say, alright, well, everything's going down, we can make it all positive just to get the number. On worksheets, every now and then, I might have an answer that's positive and you have a negative, or vice versa, and that's mine.
Okay.
Alright. So, you know right here, if D is the same height as V, it's going to be the same velocity but negative. What's the gravity, what's the acceleration going to be? Negative 9.8. Does not change. Alright. Same down here. Now, I'll tell you this also. Anytime we have problems, I say, what's the velocity of the ball just before it hits? It will never be 0. I'm not saying the ball hits the ground and it stopped moving. Okay? Every now and then somebody says, oh, it's 0. It stopped. It's done. No, everything's going to be just before it hits. So, my velocity here, if E is the same height as A, what's the velocity going to be?
49.
Negative 49. What's the gravity going to be? What's the acceleration going to be? Negative 9.8. Now, one example of this is that I always think of it because it was right after the first Gulf War, okay, which is a very, very long time ago now. But Kuwait was liberated, everybody's celebrating, and so people are in the streets shooting their guns to celebrate. All right? Then there are all these reports of people miles away getting killed by bullets coming back down. All right, by stray bullets. If you're shooting a gun in the air, the velocity that the bullet is leaving the gun is going to be the same velocity when it comes back down to Earth at that same height. So if you're shooting a bullet and it's going 250 miles an hour up into the air, when it comes back down, it's going to be negative 250. And that's not just in Kuwait. There's plenty of reports where people in the U.S., 4th of July, someone shoots their gun in the air, and then somebody dies a couple miles away. So that's just understanding gravity. Okay? Okay. Alright, next thing I want you to understand is, I already said this, but remember, if we ever have you'll have problems where I just give you the total time in the air. Okay? And I usually say total time versus hang time, or total time or hang time. The total time in the air, or hang time, is how long total, right? If I give you the total time, the easiest way to solve a problem is to split it in half. Because if you split it in half, let's say I need to figure out how high something is, how high something goes up. If I just look at half the trip, let's say it took 10 seconds to go up and come back down, right? Well, if I look at half the trip, I'm only going to use half the time and say it took 5 seconds to fall. But then I could just use, say, the big ugly. Because I know a lot of information. I know my initial velocity here is going to be 0. Right? I can say my initial position is 0. And I can have the big ugly basically just be 1/2 AT squared. So if I have a trip that goes up and comes back down, remember that gives you a lot of information. Because now you know one of the velocities can be 0. Alright, so when we talk about, you'll hear things like pop fly problems. And really what you're going to do is split the trip in half so you have one of the givens. Velocity now is 0. Okay? Don't forget, that means divide your time in half. If I said it was 10 seconds to go up and come back down, then you need to make time now 5 and look at half the trip. But that'll give you then the distance it takes to fall would also be the distance it went up. So that's how you solve those problems. Divide the trip in half. That means also divide the time in half. And then you have one of the velocities will be 0. You can use the givens at the peak. Does that make sense? Alright. Alright, I'll pause and let you copy. Okay. This is what I want you to do. Here's the time I'm going to give you. It took 10 seconds. I threw a ball so fast it was in the air for 10 seconds, which would be impossible. But the time it goes up and down in 10 seconds. How fast did I throw the ball up with? That's what you got to figure out, okay? There's some information for you. There's some hints. Figure out how fast I threw that ball up with if it was in the air total for 10 seconds. Do it now.
Its initial velocity 0?
Not yet.
Bro, I don't need.
But if you split the trip in half, it will be.
Yep.
Video. Alright. So, understand that if we split the trip in half, it gets a lot easier. So if I tell you just time it took 10 seconds to go up and come back down. And I want to know the velocity. Well, I don't know the initial velocity, I don't know the final velocity yet, so I don't have enough information there. But if I split it in half, life gets a lot easier. Okay, so if it was 10 seconds to go up and come back down, I could say, all right, well, I'm going to look at this half of it. So now my time's only going to be 5 seconds. Okay? My initial velocity now is what? 0, because it's at the peak. Gravity still negative 9.8. My acceleration, rather, still negative 9.8. And I want to figure out my final velocity. Okay? So, my list of givens, I have VF is what I'm looking for, equals question mark. VI equals 0. A is negative 9.8. And T equals now 5. Okay, because I'm only looking at half the trip. I plug that in, and again, I could have done the other way around. I could say this was my initial velocity that I want to solve for. My final velocity is 0. Wouldn't change anything. All right. VF equals VI plus AT. All right, VI is 0. Negative 9.8 times 5. And I end up with 49 meters per second. Oops. Did the same number. Now, it should be, I'm sorry, that's negative. So what I really figured out, now here's the deal. What I figured out actually was what velocity this hits the ground with. But that's also going to be the velocity I threw it up with. So if you solve for the velocity hits the ground, that's fine. Then you can say, well, that velocity is negative 49, that means I threw it up with a positive 49. Same thing with distance, okay, which we'll see next. All right, so next thing I want you to do is figure out what was the height the ball reached. We'll use the same numbers. How high up did the ball reach? Go ahead and do that. Is it recording?
Yeah.
All right. Now, this is what we're going to do for distance. The same exact stuff. Now, even though I say how high up did it reach, that's also going to be how far down does it fall. Does that make sense? So even though I say how far up does it go, I can also look at the second half of the problem and it's going to give me the same answer. So again, I say that my initial velocity here is 0. Alright, acceleration is still negative 9.8. My initial position, well we'll get to that. So I have VI is 0, A is negative 9.8, T is going to be, I'm only looking at half the trip now. So T is going to be 5. A lot of people are going to make the mistake of using the total time here. Alright? I'm looking for XF/D. I'm looking for some kind of distance. And we could do that as X or D, depending on what we got. You could use a velocity that we already got from the last question, and that would be easy too. I'm going to do it this way, and then if you want to see how to do it the other way, because we already have that, because you already answered the previous question, you have a lot of information, which means you could use either equation. All right, the other thing is, well, looking at that, using your process of elimination. 1, is there time?
Yes.
Yes. So that means the second equation is not useful. 2, is there an XF/D?
Yeah.
Yes. So that means we use the third equation. We use the big ugly. All right. What's my initial position if I don't ask for it or give it?
0.
0. Oops. My initial velocity is 0. Anything times 0 is 0. So all I have left is 1/2 negative 9.8 times my time 5 squared. What do I get? Negative 122.5?
Yeah.
Now again, negative distance doesn't make sense, but it's because I said I started here and I fell down, and I said down is negative. That's fine, and so if you said it went 122.5, that's perfectly fine, okay? And in fact, sometimes I'll probably have it as just leave it as positive also. But again, whatever I fell down here is also what I went up there. So it's gonna, either way was gonna do it. Okay? You could have done it also with just initial velocity. So, or we already figured out the VF was 49, right? And VI was 0, and acceleration was negative 9.8. If you use the last velocity from the last problem, you could have just used the VF squared formula also and solve for distance. Because you already had that information. Either one would have worked. But that's it. Alright? So every time something goes up, it comes back down. Any type of pop fly, just divide the trip in half to solve what you need. Any questions on this? That's it.
No, no.